Okay, so what I'm going to do today is show you how to use de Moivre's theorem. It's used to raise complex numbers to any power. So I'm going to have a bit of a think about just a power of 2, or raise z squared, or z to the power of 2, where z is just something written in mod arg form. So z squared is really z times z. So if it's z times z, it's really r cis theta times r cis theta. You don't have to do this all the time. I'm going to show you why it works. So this is z squared. Now we know when we multiply two complex numbers in mod arg form, we multiply their moduluses, moduli, so we get r squared, and we add their arguments. Now theta plus theta is 2 theta. So what we get is we get cis 2 theta. So that's z squared. Now we can do this any number of times for powers of 3, powers of 4, line them all up and group them all together, but you'll probably see a little bit of a pattern. So this is the pattern that any complex number raised to a power is going to be r to the power of n cis n theta. Other ways they tend to write this is you might see something like this. So cis theta to the power of n is cis n theta. So this has just got a modulus of 1 instead of r. So sometimes you see de Moivre's theorem written like this. It means the same thing. Or sometimes you see, at least I tend to like writing like this, because if you have to think about what its modulus is, you know you have to raise that modulus to the power. So let's have a go at doing something. So e.g., let's do 1 plus I to the power of 10. Now, the lunatics in the world would probably expand this. It's actually pretty easy using binomial coefficients because these numbers are 1s. But what I'm going to do is I'm going to change it to mod arg form, and then I'm going to raise it to the power of 10 using de Moivre's theorem. Now, the reason I picked these ones is because I know what the modulus is. It's 2, and I know the argument is pi on 4. So really what I'm doing is, the modulus is root 2. So this is really going to be root 2 cis pi on 4 all to the power of 10. Now, by de Moivre's theorem, what I have to do is I have to raise this modulus to that power, and I have to multiply this argument by that. So we don't see that n theta means n times theta, so it's going to be 10 times pi on 4. Now, root 2 is 2 to the power of a half, and 2 to the power of a half raised to the power of 10 is 2 to the power of 5, which is 32. You can do that in your calculator if you like, and this becomes cis 10 pi on 4. Now, it's probably worth trying to work out what this number here is, because you can't write an argument bigger than 180. Now, pi on 4 is 45 degrees, times 10 is 450. That's actually 90 degrees. So this isn't a bad answer, 32 cis pi on 2. However, if you have a bit of a think about pi on 2 is an argument which is right up here somewhere. So this part here is actually going to be, if you thought about it in an expanded form, it's cos pi on 2 plus I sine pi on 2. Cos pi on 2 is 0, that goes, sine pi on 2 is a 1, so it just becomes I. So the best answer you could write for this is 32i. I'm going to show you how to do another example now. So it's a slightly harder one. It's got really two applications of de Moivre's theorem, then you're going to multiply two complex numbers together. So what I'm going to do is I'm going to convert this to mod arg form. I'm going to convert that to mod arg form. Now it's something you know how to do, so I'm not going to go through that process, but this would have a modulus of 2 and an argument of pi on 3, and we're going to raise that to the power of 3 using de Moivre's theorem in a sec. This one here again has a modulus of 2, but its argument is a negative. It'll sit underneath, and it's negative cos of minus pi on 6. That's to the power of 4. Now, de Moivre's theorem says we raise the modulus to that power and we multiply the argument by that power. So we get 2 cubed is 8. Cis 3 times pi on 3 is just a pi. So that's that first one done. The second one, to the power of 4, is 16. Cos minus pi on 6. Multiply that together, we get minus 2 pi on 3. Now this is just two complex numbers I need to multiply in mod arg form. So we multiply the moduluses, or moduli, and we add their argument. So we get 8 times 16, which is 128. If we add pi to minus 2 pi on 3, we get pi on 3. Now that's a pretty good answer. And if the question said just do this, you could stop there. However, because the question is written in a plus bi form, or x plus iy, I just want to convert it back. So 128, you'll be told whether or not to, times cos pi on 3 plus I sine pi on 3. This is just a little bit of converting back. Now cos pi on 3 is a half, so you get 64 plus I sine, well, that part's not going to be there anymore, is it? So sine of pi on 3 is root 3 on 2, So root 3 on 2 times 128 is 64. Root 3, and we've got an I. A lot of people write that I at the front so the I doesn't get sort of sucked under the square root sign. It's probably not a bad habit. I'll make sure I do that next time. I'll take out a factor of 64 and you get 1 plus I root 3. So it's a really easy way of multiplying these two, which you have to raise to a certain power. You wouldn't expand this, convert it to Monarch form, use the Moivre theorem, then you can multiply the two together like we did here, and there's your answer. Good luck.